Welcome to China Manufacturing Decoded from Softeast, the podcast where we take you through some of the major topics facing importers and manufacturers in China today.
Hello everyone and welcome to China Manufacturing Decoded. And in today's episode, I am joined by Andy Bartlett. And if you've been listening to the podcast for a while, you know that maybe 2 or 3 months ago, we talked about tooling specifically for plastic injection molding. And then prior to that, I believe we talked about the development of new products in the toys category. So Andy has a lot of experience working in consumer electronics and especially in toys, electrical and non-electrical. Am I correct? How would
yes.
you?
Yeah, that's about me, Renaud. Yeah, hello everybody.
All right, great. And just as a reminder also for people who don't know, so Andy is one of the industrial designers that we often suggest to clients when they come to us with a product concept that is not very mature yet. So someone has to try to understand what you want to do with the product, what value it will bring to users, and so on. And then, someone like Andy has to think, okay, and you also want it to be aesthetically pleasing. So, let's try to work on some renderings and some early drawings and, starting with some sketches just to make sure that we are aligned and we know what the product roughly should look like. And then over time, go to something that's really nice aesthetically and then can be passed on for, mechanical engineering, working into all the small details and things like that. Is that a good, fair portrait? Or?
Yeah, that's a good summary, Renaud, of the process. Yeah.
All right. So as I said, in today's episode, we're going to talk again this time about the new product introduction process. So when a new, really innovative product that is not, very close to another existing product that the manufacturer has already been doing, but really a new product. When a new product is developed, we want to talk about the disconnect, the gap between expectations and reality. So a lot of people who are not in our space, let's say, they come up with an idea and they say, oh, it would be nice to make that kind of widget. And well, I just need to come up with a design and then somebody would put together a prototype and I would say, okay. And then basically they have to produce it. And I need to find some customers and sell it and reorder and sell and reorder and sell and make more and more money. That's, if I really simplify, that's not far away from what some people really, the way they think about that.
Absolutely. I guess, Renaud, I think that some of that might come from the idea that we're all at heart consumers, so we all love stuff and buy stuff in our everyday life. And I think much of the time we never really stop and consider the energy and the effort and the human endeavor that often sits behind a beautiful, simple, elegant thing that we love. Particularly, I think the process is particularly requires particular investment when you're doing something new. It might be new to you. It might not be. There may be a category or a segment in the market that's very well established. But if you're doing something for the first time, it generally takes much more effort than the second and third and fourth. And as you get better and better at doing it, you use some of that previous investment of knowledge and wisdom and skill and bring it to the next development. But particularly the first time round, it can be really, really tough going.
Yeah. No, you made two great points. Number one, a product might seem relatively nice and simple, but there might be a ton of work behind it.
Yeah.
And that, people often think of the Apple products, but they don't know how many iterations
Yes.
of early design sketches and working with, specialists of the technologies and the materials and everything to find, to explore different avenues, and then, okay, these two are more promising. Let's go ahead, talk about it with the manufacturing guys and see what it would entail. And then, there's these and these issues. We also need to think of, how to make it reliable. We need to make sure that we use really good components. We need to make sure it's possible to maintain it in our ways. We need to make sure that the aesthetics are perfect. We need to make sure and then, and they have so many engineers, that they actually even sent to the factories to get it into manufacturing. People really have no clue about that.
No, you just reminded me of something, because I think you're obviously coming at it from a product execution perspective, but I spend a lot of my time working in concepts, and so you're talking about bringing the product to market. Well, actually, even getting to the point at which you have an agreed concept that wants to is a huge thing. I worked once for Panasonic, and for the first 3 years of working there, not one of my concepts ever went to market. So you imagine, that's the sort of investment that, if you do have the resources and the development people there, that is the sort of stuff that sits even behind the stuff that you see.
Imagine how many concepts are developed in Apple, Microsoft, HP, and all these people, all these companies, and never go anywhere. But how many man years of work are going to that, and that's part of the early discovery of what would a nice concept be, right? Where the user is happy, we can make our market projections, the cost guys are happy, and the brand guys are happy, and everybody's happy. It takes an enormous amount of work sometimes.
Yes, by which time, of course, the market's moved on and the product's no longer relevant. But hey, no, I mean, but let's just assume that we get to a concept. The early design work before pre-tooling can really be the sort of tip of the iceberg with the mass or the biggest portion of effort still to be done in terms of signing the tooling off and going through the tooling validation process, and then developing packaging, developing assets for your online presence, distribution and so on and so forth. There is an unseen. I mean, the iceberg is quite a good analogy, I guess. With 10% stuff that you see and 10 or 20% stuff above the top of the water, and then 80% below it, the stuff that maybe as a consumer you never consider happens.
Right. But let's go back to what you mentioned, the early design work, because that's really what determines so much of everything else in the project, right? So that's why it's so important to do that right. It's so important to work with good people and really take the time to do it right? I guess you saw these statistics, but that's based on real data. I forget where I saw it. In the book about the textbook about DFMA. Anyway, someone did a study and found that the cost of the design itself, when you put it together with the cost of tooling, product, purchasing the components, manufacturing, distributing, and everything, is 3, 4, 5% of the total.
Yes.
However, it determines something like 70% of the total cost.
Yes.
Because you pick the materials, you pick the technology, you pick how it works, you pick how simple or how complicated it's going to be.
Yes. You build. It's interesting going through. If you look at the number of decisions that you make in the development in a product's life cycle, many of the core decisions are made really early on, and the kind of whole project stacks and builds on those decisions, like material and processes, and and because they're made so early in the development process, the consequences of going back and changing them, if you get them wrong, or if they prove to be somewhat flawed, then is huge. And I guess that's what you're saying about where the cost of those early design decisions that's where you kind of set the roadmap and where you can go deeply wrong, and going back can be very, very expensive.
Right.
So
let's take an extreme example, of something that was really, really poorly designed, and then it's just made the whole project go down. And there's a lot of such examples, right? Maybe picking a technology that is not mature, so something that where the manufacturing readiness level, as they say, is pretty low. Well, you're going to give a lot of headaches to the manufacturing guys, right?
Yes.
It's just an example.
Yes. Yeah, it's very easy to be kind of seduced by certain processes or finishes or technologies that will just draw in so much of your time and effort, and it will require lots of other people to do lots of R&D and making sure that it's fundamental to your product offering is really important, so that you're not wasting that energy. Even using something that's kind of niche, a process can be really troublesome, and cause you lots and lots of troubles, downstream, and really cause you big headaches that may actually not be worth it, I guess.
Yeah, right.
Which I think the best thing, if I'm looking at, if I imagine myself developing a product, often, as a person coming with an idea, they're not going to know a lot of the stuff. So I think it's essential that you surround yourself with people that you trust and people that have experience. But people at the same time that are willing to try. We don't want to become too routine in what we do, and there's always opportunity to innovate and to expand our knowledge and push it and stretch a process. And I think that's an intrinsic part of what we should be doing every time, when we do develop new products. So it's a very delicate balance to be had, and often the skill in the process of taking a product to market is to say no early, I guess, and not go too far down a route that's going to ultimately cause you some pain.
Right. Yeah, that's where experience comes in, right?
Yeah.
If you've been doing this for 25 years, then you can make the calls much faster and more accurately probably than a more junior designer. That makes sense.
Yeah.
I should also stress the importance of procurement and sourcing, picking the right the right suppliers for the critical components, because that also can derail the entire project. I mean,
yes.
Worst thing is you do some kind of electronics, and then, as a lot of companies I've found out, unfortunately, the ST microelectronics processor, the price went up 20 times, or the screen just went out of end of life. Right?
Yes.
That really happens quite often, actually.
Yes.
So picking the right components. Also, if you need high reliability product, reliability is totally determined by design, and that's what people don't understand, is that they think of quality and then they think of the guys doing the assembly on the line. But then if they want the product to keep working for 2-3 years, the design itself has to be reliable. And that comes from design, from making sure that thinking of the stress points and the redundancy if needed and things like that, and also picking the right component suppliers that already come with proven reliability levels, right?
Yeah. Renaud, I wanted to just go back on something. Getting to the answer no, or stopping a development or a development track is really important. I was listening to a podcast the other day, and they talked about a thing called the sunk cost fallacy, which is also known as the Concorde fallacy. Now, you're a French guy and I'm an English guy, and anyone listening that's younger than, say, 35 probably doesn't really remember Concorde, but basically it was a supersonic aeroplane. And the concept was to fly people supersonically across the Atlantic. And basically the project ran 10 times over cost. And it's a really interesting analogy here because they carried on plowing the money in because they'd already invested so much energy, time and money that they couldn't possibly walk away from it. So I think it's a trap that we can fall in when we develop product, and that's the sunk cost fallacy. It's we've taken so much time and effort to get to where we are now. We can't give up now. We're giving up, or not giving up, but changing direction, pivoting, reevaluating might actually be the most prudent way forward. I just thought it was an interesting little insight.
Definitely. And it's quite relevant because there were some studies that showed that the bigger the project, the more complex, the more elements going into it, the more likely it is to go over cost. And it's pretty much guaranteed actually to go over cost when you compare original projections versus the real cost, real amount of investment, if you want.
Yes.
And sometimes it's times 10, yes, as you say. And guess what? If you want to develop a new product, and there's a lot of things that come into it, a lot of different teams and different expertise and different challenges and so on. Well, the same thing is at play here. If you really focus on what creates value for the users and you try to make the product relatively simple, then not only would it be faster to develop, less risky, but also there's a lower risk of you going over your budget if you want.
Yes.
And the more complex it is, then the risk actually goes up exponentially.
Yes, this is something that I learned from my days in the toy industry. We used to define a product. You used to have to be able to describe a product in one sentence. If you couldn't describe what your product did in one sentence, and it needed 5 sentences, you're probably guilty of putting too much into it. So that maxim of keeping it simple is really, really good advice and will keep you true and honest.
Oh yes.
Certainly, from in terms of cost and time. So try, when you have a concept, there's something I try and do with the people I work with is say, okay, tell me what the product is, but in one sentence, And the idea actually in the toy industry, it used to be, can you tell the story of your toy in a 90-second TV advert? And that's another interesting way of looking at it. If you were going to sell your product, could you describe it quickly in a really often I think it's called an elevator pitch, isn't it? Where could you pitch your idea to an entrepreneur in the elevator as they're going for their lunch, basically? And again, it's a really nice way of just keeping you focused and not trying to do too much, and not bloating your product specification and not allowing yourself to have project creep or specification creep as you go down and say, oh, it could do this and it does this and it does this and it does this, because people don't care after the first 1 or 2 what it does. There's a certain hook that you've got, and that's what they're buying into, normally. So keeping things simple. I don't know whether this translates into French, but we say keep it simple, stupid, and that's KISS. So we kiss everything. Is a nice little guiding principle, I think.
Right. Yeah, I heard about that one sentence theme, for new movies in Hollywood too. I think they try to do the same.
Yeah, definitely.
All right. Okay. So basically, yeah, takeaway for people who listen about let's say the early design work is there's a lot of exploration. You need to take your time. And as long as you are in exploration mode, you haven't really nailed the concept. You can't really plan ahead very accurately about the rest of the journey, right? And it's all about feasibility study, proof of concept, exploratory concept, and options. And this is the kind of vocabulary that you would use, right? I guess.
Yeah, that's right. And it's really, this is where exploring ideas is cheap and cost effective and efficient, should I say. Exploring ideas, once you've made a tool, well, you can tell me about that, it becomes slow, it becomes painful, and it very quickly becomes very expensive.
Right. If you have a drawing and it's just in your CAD software, or even just still a sketch, making a change is not that much work. But as you say, when the tooling is made, it might be 20 times more expensive, maybe 10 times more expensive.
Yes.
And then when you have already production on the shop floor, don't even mention it.
Absolutely. Yes.
Right. So that's for the early design. Something that we don't cover very often here on the podcast because really we're not really involved in that. But it's good to talk about that with you. What about the rest of product development? So let's say product development is to get all the way to a prototype that is approved. Looks as you want, works as you want, including packaging. Obviously, people often forget this one.
Yes.
And that can be a ton of work, right? I mean, again, let's talk about extreme examples. I was looking at the video about Jeff Bezos' Blue Origin rockets and how many times they made an engineering build and fired the prototype up, and they were quite deliberate about the way to do it, but it took them, I don't know, maybe 7 or 10 years to get to the point where they say, okay, it works safely enough to send our multi-billion billionaire, up into the side of the earth, right?
Yeah.
So that can take, sometimes it takes more than 10 prototypes for complex electronic products, and I'm just talking about prototypes, but of course that wood process kind of starts again after tooling is made, if you have very high expectations of the finishing, right?
Yeah. I mean, just think of the idea of Mark Zuckerberg's catchphrase is move fast and break things. Yeah,
yes.
That's a really good one when you're looking at your prototyping and how you prototype and prove out concepts, and also something from borrowed from the world of agile software development, and that's minimal viable products, or minimal viable propositions. And that's keeping with prototyping, keeping accepting good enough to get to move quickly, because in search for perfection, particularly in the prototyping phase, searching for perfection will slow you down and prevent you from learning things really quickly, which may be really important in particularly if you're doing something for the first time. So having that sort of quick, agile mindset, and the quickest way to consider or communicate design is literally sketching, and that's a really undervalued part of the development process. The minute that you go to CAD, it slows down. It invariably slows down. But when you do go to CAD, you can still keep yourself loose and free and not worry too much. Have the kind of skill and within, or use someone with the skill that's able to know what's possible, but not to actually have to define it. So keeping stuff just about developed enough or defined enough to move you through the development process. And, particularly with 3D printing being what it is these days, you can get forms really quickly, really, really quickly, that are good enough to put in front of people, customers, people that you may be selling to, and show them physical objects. So,
right. Yeah, because if it's a new product, you need to get the feedback from typical users, right?
Yeah.
And would you rather spend 6 months to get a perfect prototype, that's perfect in your mind, but maybe you went in the wrong direction? Or would you rather do some quick iterations and show some people something once a month? You would learn so much more by doing once a month.
Yeah, definitely. And these are all principles that are very much well defined in agile product development. So that's, for me, that's, if you were looking at, if I was going to sort of recommend, I'd recommend that actually people interested in development, even just
any book you suggest on that? Because it seems to be very focused on software development. Everything around it, agile,
it's really interesting, Renaud, because again, so back in the 70s, the Japanese manufacturers of cars developed just-in-time engineering, and in fact, those principles moved from engineering into lots of supply chain businesses. And one of them was software, and they took it and they morphed it into agile and developed agile software development processes.
So it all comes from, let's say, Toyota and Honda and these companies.
Yes. Now the cycle of the full circle, it's gone full circle now, because the agile product development models are now being applied and used back in the manufacturing processes. So, yes, it does start there. I mean, off the top of my head, make Google your friend on it. I mean, there's big books that you can read, and that's probably no need. But just the idea of moving quickly, of minimum viable propositions, and learning.
Having different people work together, designers, engineers, already involving manufacturing people also to get feedback.
Yes.
Yeah, right. Yeah. Concurrent engineering, try to do make things faster by overlapping certain phases and so on. Yeah, that makes a lot of sense.
Yes, it does. Yeah. It's interesting stuff.
Okay. So we kind of covered, product development, and so a lot of people who want to develop their own new products, from what I observed, they kind of find ways, to work with engineers and with designers and get some prototypes and move the ball forward. One of the big mistakes they make is that maybe they don't have the latest versions of all the deliverables, all the drawings and the schematics and the bill of material and so on. And that is a big mistake. But apart from that, by hook or by crook, people kind of find their ways, and maybe the design is not very good. But then where they fall off their chair, literally, is when they find out that, the manufacturer that they lined up actually hasn't prepared anything for manufacturing their product.
Right.
And that's really typical. I mean, I'm sure you've seen that. Just last week, I was talking with someone in the US, very nice person, and they did all the engineering of their new product. Really, they designed from the ground up. They did all the engineering. They selected all the components, relatively high quality components. They want to do everything right, and then they get prototypes, and they say, we tested the prototypes like crazy for a month, and it's really nice. Okay, so the manufacturer says next step is to wire the money, and the 30% Usually they call it deposit, but they never send it back, but they still call it deposit, and go straight into mass production. And then, of course, I ask them, well, okay, where's the quality standard? Well, where's the testing plan? Have you done the certification? So, you wait until mass production is done to check if it's FCC compliant and so on. Are you sure? Well, you're not going to do any pilot run. So how have you validated that? Everything can be made properly? And of course, I mean, that person is smart and recognizes, yes, all this work has to be done. So he told the manufacturer, who said, trust us, we make that, that general kind of product, but every day, it's fine. We know what we're doing. Just trust us. And and then, of course, the customer, keeps the buyer keeps pushing, keeps saying, guys, this is really different from the stuff you make every day here. We designed this from the ground up. You have no idea even of the, what are the risks? You don't even tell me about the risk in production. So you're not aware of it. That's really scary. And they say, well, if you really want some samples for certification, it's going to be, X dollar per sample, really high number. Basically, they don't want to play the game. And well, that's a bad sourcing decision right here. Of course, they should not work with these people, but also they did not plan for it, so they did not communicate about their process. And then, of course, manufacturers making money by going into mass production, right? So, and that's rather typical, right? I'm sure you've seen this kind of situation.
Yeah, for sure. I mean, it's very tempting, isn't it, to expedite a development process, and particularly if you're under pressure, either budgetary or time. It's very tempting to bypass certain stage gateways, but. And I think you can have a full development path and a quick development path, depending on the nature of the product you're doing and the complexity and the challenges. But there are certain stages that can't be forgotten, and these are very well tested, tried and tested. Pathways, and people call them different things, but basically a really good way of thinking about it is going from prototype and by stages of increasing volumes getting to mass production.
Right.
You don't jump from a prototype to mass production. You tentatively go through 3 or 4 different development gateways, each time pausing, reflecting, reviewing, testing, checking, and approving. And if you don't do them, the short-term gains are just can be wiped out in an instant through long-term losses. The risk is very high.
Yeah, because when you go into mass production, you have some issues. That's extremely costly.
Yeah, the liability to you, as a customer, the liability, just the financial implications of. I've seen it before, where the only meaningful testing is done on goods out, and products failed, and it's so expensive, to rework. Even if you catch it before it goes, the further away from the factory you get, the more expensive. So. This is an investment. The development process is an investment, and one which will save you a lot of heartache, a lot of pain, a lot of money and time. Albeit it might feel somewhat laborious or slow. Whilst you're doing it, hey, I've got a prototype. Look, here it is. Why can't we just make that tool and get it out the door? And obviously we all have to, as long as we remain motivated and focused and efficient, then we have to, the process needs to be respected, because it's done. And nearly every project I'm asked the question, why do we do that? Why do we do that? Why, or can we not do that? And, once you sit down and explain and go through the risks and what you find and the sort of things that you're looking for, then, normally it's all fine and the process is followed. But it is sometimes a process of educating.
Right. Yeah, absolutely. And it's really about risks, right? You mentioned, yes. You explained the risks.
Yes.
It's also what we try to tell our clients. You can just go ahead without that. But what if? And yes. What if? And then they're like, really?
Yes.
Okay. Well, yeah, that would be a big problem. Okay. Then that's the way usually people do to cover that risk.
Yes.
That's
yeah. Showing due diligence through your process is a if something, God forbid, does happen, having an auditable trail and a development process is very valuable.
Oh yeah.
Very reassuring as well, I think. And if you are developing a new product and putting it into the market at a significant number, I certainly would sleep better at night knowing that I'd followed the correct development path. And just as an investment, would rest easy knowing that investment had been made.
And again, let's take an extreme example. There's a recall. Your product causes injuries or death or something really, really disastrous. And a judge is asking you questions, and if you cannot answer the questions, they will say you were negligent,
yes.
And then if you say, well, I didn't know that people usually do that, this is no defense.
No, indeed.
Defense. But if you say, no, we did, this is our risk analysis, and you see that we covered the foreseeable safety failures, and we identified ways to address them. We did some reliability testing to address that. We did a new, some engineering changes to address it, and yada yada yada. And this component, the battery, will work with a fully certified manufacturer that's that give us all these assurances and so on. Then they will say, well, right, okay, you're not lucky, but you actually did much more than others, that we usually see here.
Yes. I mean, and again, you don't want to be literally developing a product is hard enough. I mean, having to deal with those sorts of issues is the last thing that you want to be getting involved with. So just, take advice from sound people that have done it many, many times, and trust in the process, and accept that you can push hard, but there are non-negotiable gateways in your development process, and things that need to be done, that should be done, that morally and ethically and legally need to be done in that process. And it's the iceberg. You go back to the iceberg, and it's hard. It's really hard. Getting your first product to market is really, really hard, but it gets easier and easier, I think.
Oh yeah, especially with the next versions of the same product.
Yes. Well, that's a really good point actually you make there, because there's nothing wrong in having a roadmap whereby you maybe go to market with your minimal viable proposition, and know that season 2 or version 2 is on the roadmap, and you spread the development risk so that you can invest or get to market as quickly as possible, and then build the brand, build your brand moving forward with a more sophisticated execution of what you're doing, or engaging with newer updated technology. I'm doing that at the moment with in the vaping sector. The technology, getting to market quickly with existing technology, using may only allow you to achieve, say, 80% of what you want, but actually getting to market with the product and knowing that once you build momentum, you can go back and explore the new technologies that are available and have the time to do so, and the energy and the resource to do so, is a really valid way of putting your product, getting your product to market, and sustaining and growing your brand.
Yes, well, very well said, and it fits back to what we said before, the simplicity of your first version. Yes, that's great. I think all of this is really excellent advice. So, yeah, thanks so much, Andy. Thanks for sharing your experiences and providing all this great advice.
Pleasure.
And to our listeners, thanks for listening. From time to time, please go into whatever software you use, Apple Podcasts or Stitcher or something else, and give us 5-star. It really helps us a lot. And you see, we can bring some great people, interview them, and get some really good takeaways. Okay, well, thanks everybody. Thanks, Andy, again.
You're welcome. Thanks, Renaud.
Yeah, and we'll be back next week with another episode. Thanks a lot.
Thanks for joining us. If you've enjoyed today's podcast, don't forget to like and share, and you can subscribe on Apple Podcasts, Spotify, and all other places that you get your podcasts from. See you next time.